Hi folks, this video is starting unit 3. This is a pre-skill to the unit, so that's why this is 3.0. So this unit is called Radical and Irrational Functions. We're going to start with some vocabulary and simplifying radicals, building off of an old skill and branching it into a new skill. So some vocabulary that is some old vocabulary, but we have to make sure that we remember what this is and keep on building our knowledge, is between rational and irrational numbers. So a rational number is a number that can be written as a fraction. And obviously a fraction, you're going to have that division bar and you're going to have some sort of numerator and denominator there. A irrational number cannot be written as a fraction. And so just looking at some examples of these, so some patterns we might see. So for example, let's look at radical 25. So we know that radical 25 simplifies to just 5, and 5 can be written as a fraction. So an example of a rational number is radical 25, because again, it can be simplified to just 5, and 5 can be written as a fraction. So we got that one taken care of. Let's talk about then pi. So from what we know about pi, it's a number that will never end. And obviously we have a symbol for it, but it starts off as, 3.14, as you learned back in middle school, and it keeps on going to 1, 5, 9, 2, 6, 5, 4, 5, 4, and it's just going to continue on and on and on. Now, if this is going to continue on and on and on, so it doesn't end, and notice that none of the numbers are repeating. So for irrational numbers, as a decimal, they won't end. And no repeating patterns. So that's kind of like a little added bonus there to understand won't end, no repeating patterns. And so for sure pi is irrational because again, pi will never end and there's no actual patterns within the numbers. It's just going to keep going in over and over again. All right, let's look at this next one, 0.97. Well, 0.97, I could actually write this as a fraction. I could do 97 over 100. And so because this can be written as a fraction, this is a irrational number. All right, got that one taken care of. All right, radical 2. Well, if we think about it, what is the square root of 2? Well, it can't be 1 because 1 times 1 is 1. And it can't be 2 because 2 times 2 is 4. So we have to recognize that the square root of 2 is actually a decimal. It's going to be 1.414213562, and it keeps going. So again, notice our numbers. There's no sort of pattern here, and it keeps going. So what category would that fall under? That would be an irrational number, because I can't write this as a fraction. Again, it's going to keep going, it won't end, and there's no patterns. So radical 2. So let's make a comparison between our radicals here. Radical 25 was a rational number, but radical 2 was not. It was a irrational number. What do you think the difference is? Well, hopefully you thought that the difference is that 25 is a perfect square. So notice how we could have perfect squares. And that would kind of fall under that category of irrational, even if there's a radical there. So a misconception some students have is that an irrational number is a number with a radical, and a rational number would not have a radical. Well, you're kind of right as long as you simplify it. All right? So let's look at the final one. We've got negative 40 here. We've got negative 40. Now, I could write negative 40, and how could I write that as a fraction? Oh, yeah, for sure. I can just put it over 1. So that means that negative 40 is a rational number. And again, that's because I can take negative 40 and divide it by 1 in order to make it a fraction. So hopefully that couple of examples helps you kind of know what is a rational number and what is a irrational number. Again, we need to be able to create a fraction. If we cannot create a fraction, it's an irrational number. All right, so that's one part of our vocabulary. The next part we've gone over before, but we're going to start expanding this idea. So let's fill in some ideas. So obviously we should know that this little symbol that almost looks like a little check mark here, this is a radical symbol. Now whatever is underneath the radical here, anyone remember what that is called? Whatever is written underneath is called the radicand. Then technically we have a little number, a little one that's written kind of inside the little check mark here of the radical symbol. I always tease and call it the armpit because this always reminds me of a little arm. And down here, this would be a little armpit down in here. So I always call it, the armpit. But this little number here is called the index. So again, that index is going to be a small little number kind of written inside the armpit. And then we could have a number that's written in front of the radical. And just like with parentheses, if I had parentheses and I had a number written in front of the parentheses, what would we call that number? Well, hopefully you would remember that we would call that number the coefficient. And if you know with parentheses, as long as there's no sign in between, we know it's a times. So notice right here how there's no sign between. So then we would assume it's multiplication, which is why this is called a coefficient. If there was a plus sign or a minus sign here, it would not be a coefficient. So for example, if I had some sort of number and then like plus a radical here, this would be now a constant. Or if I had like a number minus a radical, that number in front would still be a constant because we have the symbol in between here of either this plus or minus. If there's no sign, no symbol in between, then we assume it is multiplication. And if it's multiplication, it's a coefficient. So just to show you some examples and just to make sure that we're all on the same page. So our first example here, I've got 3 and then radical 6xy. Now notice how we don't have a number written on the inside here. So if the index is not written, we assume it's a 2. So technically our index is a 2, and we would call this a square root. And again, square meaning 2. And if the index is not written, we assume it's a 2. All right, your radicand is written on the inside. So hopefully you would recognize that as 6xy. Now 3 is written in front of the radical symbol. It's larger. It's not like the index. The index is meant to be smaller. And notice how there's no sign between the 3 and the radical. So that means 3 is a coefficient. All right, let's look at another one. Now notice with this one, notice how there's a little 3 inside the armpit there of that radical symbol. So remember the little number written there, that is called the index. So our index is 3 because that little number is written on the in little armpit of the radical symbol. Our radicand is whatever's written on the inside, so that's going to be 10x to the 4th. Now careful here, what's your coefficient? Our coefficient is a -1. And technically that -1 is being multiplied with the radical because there's no sign in between. There is a sign with the 1, but there's not a sign between the 1 and the radical. And that's the difference. So our coefficient here is a -1. All right, last but not least. So what's my index? Well, notice there's no index written, so what do we assume that it is? We assume the index is 2 because this is going to be a square root. Just to come back to the second example, what would it be called? What type of root would it be called if my index is 3? Hopefully you said cubic root. So remembering that number, the index, kind of indicates what type of root it is. What's our radicand? It's going to be x plus 5. And do we have a coefficient? Yes. Yes, there is a sign in front of the 2, but again, we're looking in between here, in between the -2, so in between the 2 and the radical, there is no sign. So that means that we're multiplying between the -2 and the radical. So -2 would be our coefficient here. So this is your basic vocabulary for radicals. Now, we've learned in the past how to simplify our radicals, and we're going to continue that process with this video. So let's look at those. All right, so if we're looking at this, okay, well, this is looking a lot different because I've got not just a number underneath my radical, I've also got variables and exponents. So that's where we're kind of moving to, is being able to simplify radicals that also have variables and exponents. So I put the process here on the side for you. Obviously, this is going piece by piece. Once you get the hang of this, the process goes by a lot faster. But while you're new, I just took it one piece at a time. So let's look at our first step. Our first step here is if there's a negative inside the radical, we need to pull out the negative and switch it to an I on the outside. Well, if I'm looking on the inside, I do not see a negative on the inside right here. So I think I'm good with that step. All right, step number 2. So with the number under the radical, break down the number into its prime factors. Okay, we've done this before. We can do this. So let's look at 147, and we need to figure out what it's divisible by. Well, 7 is an odd number, so we can try 3. Oh, that works. So 3 and 49. I'm going to circle 3 because that's prime. I can break down 49 into 7 and 7. Some of you might recognize that as a perfect square. Notice I've got my 2 7s here. Those are both prime. Now I'm going to be looking, so I've got my prime factorization done, so that's step 2. We're going to circle groups of factors that match the index. So let's think about this. What is my index for this problem? Well, my index, it's invisible, so we assume that the index is 2. So I'm looking for groups of 2 or pairs of factors. Because again, pairs would imply 2. And just like from before, if I've got a pair, how many are going to the outside? Hopefully you know one of them. And the reason being is because technically what we're doing is the square root of 49, and the square root of 49 is 7. So let's come back to our process. So we circled groups of factors that match the index. Again, my index is 2, so I was looking for 2 of a number. So I've got that. Pull one of the number from each group and place on the outside of the radical. Cross out the groups as you go. We did that. Cool. All right, step 5. Multiply the numbers on the outside of the radical. So what numbers do I have on the outside? Well, I have the numbers 7 and 2. Well, 7 times 2 is 14. Then I've got my radical here. And let's look what's left over. So I should have a 3 left over. And then I still have my variables here, m to the third and n squared. Okay, so I've got that done. All right, so now step 6. If there are variables under the radical, expand each variable. Okay, we can do that. It might be kind of, a little bit long here, but I've got 3 times, and if it's m to the third, that's going to be 3 m's. 1, 2, 3. I've got n squared, so it's going to be 2 of them, n times n. All right, so I expanded each. So now let's look at 7. Circle groups of variables that match the index number. Oh, okay. So my index number is again 2. So I'm looking for pairs or groups of 2. Well, I've got 2 m's and I've got 2 n's. All right, so that's step 7. Got that down. Okay. Pull one variable from each group and place on the outside of the radical. Cross out the groups as you go. Okay. Well, let's do kind of like we did with the 7s. All right, I've got 2 m's. So again, I'm going to pull 1 to the outside. Here, let me color code. I'm going to pull 1 to the outside. So m. Cross that out. I've got 2 n's. I'm going to pull 1 to the outside. Cross that out. All right. Well, I don't have another m, so I'm just going to leave that there. Let's look at the next step. Okay, so that was step 8. Step 9, make sure all the coefficients are multiplied together. Remember that coefficients would be multiplied on the outside. So my coefficients would be right here. So 14 times m times n would just be 14mn. And all radicans would mean on the inside. So outside and then inside. So those need to be multiplied together. So radical here, and notice I've got 3 and an m, so just 3m. And at this point we are done. So this is my final answer here, my final answer. So 2 radical 147 m cubed n squared is the same thing as 14 mn radical 3m. So we're just simplifying, we're not solving. So these are equivalents, but one is simplified. All right. Well, let's go through this process again. It might be helpful to see a couple of examples just to make sure that we have this process down. So let's look at another one. All right, example number 2. So let's go through this process. Just make sure that we're good. All right, first things first. I'm the realist. No, you are too. Okay, just kidding. Jokes. All right, so number 1, if there's a negative on the inside of the radical, plot the negative, switch it to an I. Now there is a negative here, but is this negative on the inside? Hopefully you said no. So this step is done. I still don't have an I because that negative is on the outside. If there was a negative on the inside, then that would have changed the game. All right, so step 1 is done. Let's go ahead and let's look at step 2. So step 2, with the number under the radical, break down the number into its prime factors. Well, we can do that. I've got 128 on the inside. And I'm going to be breaking that down. Now, 8 is an even number, so I know I can take 128 and I can divide this by 2. So it's going to be 2 and 64. 64 can be broken down into 8 and 8 because that's a perfect square. 8 can be broken down into 2 and 4. And that's also going to be a 2 and a 4. And then 4 can be broken down into 2 and 2, 2 and 2. Now, what's a little bit different here? So I broke down the numbers. I broke down my number on the inside underneath my radical. I got that down, step 2. Now notice step 3. It says circle the groups of factors that match the index number. And this is where things get a little bit different because notice your index number here is a 3. So that means you need groups of 3 factors. So notice right here, I've got 3 2s, and I've also got 3 2s right here. So I've got 2 groups of 3. 1 2 3, 1 2 3. Notice you still have a 2 left over up here, so don't forget about them. All right, so let's look. Step number 3, circle groups of factors that match the index. I got that. Pull one number from each group and place on the outside of the radical. Cross out the groups as you go. All right, let's come back to our problem. So I've got this group right here of 2s. One of them's going to come on the outside. Cross that group out. I've got another group of 2s. Let's bring that on the outside and let's cross that group out. Okay, I've got my groups taken care of. Okay, step number 5, multiply the numbers on the outside of the radical. All right, so we need to multiply 2 times 2, which is 4. And then 4 times negative 8 is going to be negative 32. Okay, so on the outside I have negative 32. And I still have underneath my radical, so I've got 3, and my little index there, and then my radical, I've got a 2 left. Oops, I got a 2 left over. And then I still have these variables, x to the 5th, y to the 3rd. All right, so I got step number 5 done. Notice step number 6. If there are variables under the radical, we need to expand them. Okay, well, I guess let's rewrite one more time here. So negative 32, index of 3. I'm going to make that a little longer for myself because I know I've got 2 times. Notice I have how many x's? I've got 5 of them. So 1, 2, 3, 4, 5. I've got how many y's? 3. 1, 2, 3. Make my radical a little longer. Okay, so I got that done. Step 7, circle groups of variables that match your index number. So what's my index number? My index number for this, in this case, is a 3. So I'm circling groups of 3. So here's 3 x's, and notice here's 3 y's. Okay, got my groups. Step 8, pull one variable from each group and place on the outside. Cross the groups as you go. Okay, well, I've got 3 x's here, so that means one's going to go on the outside. I've got 3 y's, one's going to go on the outside. All right, I don't have any other groups, so I don't need to cross out anything else. So that was step 8. And last step, step 9, make sure all coefficients are multiplied together. So remember, coefficients is on the outside. So on the outside here, I would have negative 32x times y. And then all radicands, so that's on the inside, are multiplied together. So don't forget to write your index of a 3. And then there's my radical, my cubic root here. Notice I have a 2 here. And then what's x times x? That would be x squared. And this is my final answer. And again, this is simplified from my original. All right, thoughts there? Hopefully you're thinking. If you need to, rewind the video, replay it, make sure you know where numbers came from or where it went. And again, this process goes by faster once you have the hang of it, because you can do multiple steps at a time. We're going through one piece at a time until you get the hang of it. All right, let's look at one more example before you give some problems a try. All right, let's look at example 3. So same process, just a new problem, making sure that we kind of make some comparisons as we're going through the process. All right, so let's start again with step number 1. Step number 1, if there's a negative inside the radical, pull out the negative, switch it to an I. Ooh, look at this one. I've got a negative right there. Okay, so what we're going to do, we're going to be taking that negative out. And we're going to be switching it to an I. So I know I have 4i square root here because my index, notice how my index is invisible. So I know that this index is a 2. So this is a square root. And I still have now a positive 81 x cubed z to the 12th. Okay. So got the I taken care of. Let's look at breaking down our number. So 81, we know that can be broken up into 9 and 9, 3 and 3, 3 and 3. Now this is a little bit easier because this is a square root. My index is a 2. Some of us might know offhand that the square root of 81 is 9, or you could even say the square root of 9 is 3. You could break it down like that. For those of us who might not be as familiar, remember that we are going to follow the general process here. So we're circling groups of factors that match the index. Well, my index is a 2. So notice I have 2 3s and another set of 2 3s here. I'm going to pull 1 from each group and put on the outside. So that one's going to get a 3. And this one's also going to get a 3. Okay. So we did step 4. Step 5, we're going to multiply all the numbers on the outside. So we're going to multiply these together. So we know that 3 times 3 is 9. And then 9 times 4 is 36, and don't drop that I. So 36i. All right, let's look at our radical here. Now notice I don't have any numbers left over from after my groups. So all I have left over are the variables here. So we've got x to the 3rd, z to the 12th. All right, so step 5 is done. Now we need to expand our variables. So let's go ahead and do step 6. I'm going to give myself plenty of room because I noticed this is z to the 12th. All right, so I've got x cubed, so that's 1, 2, 3. Z to the 12th, I'm going to go ahead and kind of stack it a little bit. So I'm going to do 6 and then 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, which gives me a total of 12. All right, we got that done. Step 7 says circle groups of variables that match the index number. So again, my index is 2, so I'm looking for groups of 2. Well, I've got 2 x's. I've got two z's, two z's, two z's, two z's. Oh look, two z's and two z's. All right, step 8. Pull one variable from each group and place it on the outside. Okay, well, I got one group of x's. Cross that out. I know I have an x out here. Now notice, how many groups of z's do you have? You have 1, 2, 3, 4, 5, 6. So technically you would have 1, 2, 3, 4, 5, 6. All right, so let's make sure our last step is done. We need to make sure all the coefficients are multiplied, so everything on the outside, so that's this, are multiplied together, and then all radicans, that would be on the inside, are multiplied together. Now let's look at all of this, because this might get a little messy here on the outside. Now we know we want to start with 36, and you can go ahead and put your I here. Notice if we go alphabetical, we can do our x first. There's just one x. And notice how many z's do we have? We have 6 of them. So we should be able to say z to the 6th power. Then we have a radical, and that x is left over there. And this is our final answer. All right. If you have the hang of this, that is wonderful, great. I can show you a little bit of a shortcut with the variables. Now, if you're feeling a little confused, I would personally maybe not look at the shortcut just yet. You can if you want to, but the shortcut is optional, okay? So the shortcut works because of these groupings. So let me show you the shortcut. So shortcut with our variables specifically. So you still have to go through the process with the numbers and the negative underneath the radical. But again, there is a little bit of a shortcut with the variables and the exponents. So let's take a look. So step 1, we still need to identify if there's a negative underneath the radical. Yup, there is. So when I pull this negative on the outside here, we're going to be rewriting that with an I. So 3i, and then square root of positive 20, x to the 7th, y to the 4th, and z to the 3rd. All right, so again, we're going to be breaking it down. So we're going to be breaking down our number underneath the radical into its prime factors. I've got 5 and 4. 5 is prime. And then 2 and 2. All right, circle groups of factors that match the index. We'll notice that we don't have an index written here, so we assume that the index is a 2. So I need groups of 2. So notice I have 2 2s here, and one of them can go on the outside. All right, let's go ahead, and that would be step 4. Step 5, multiply our numbers on the outside. So I've got 2 times 3 here. That's going to be 6i. Notice what I have left over. I have 5. And then I still have our variables here. So x to the 7th, y to the 4th, and z to the 3rd. All right, that step's done. All right, step 6. This is where our shortcut comes into play. So we are going to identify our variables underneath the radical. And we are going to divide each exponent by the index. Once we divide, we're going to put that variable in the new exponent on the outside. If the exponent does not divide evenly, leave the extra as the exponent of the variable under the radical. Now, it is a little bit wordy of a step. It's probably helpful if you see this happen. So, for example, I'm going to think about my first variable, x to the 7th. Now I know that my index is 2. So if I take 7 and divide by 2, I know that it will divide evenly three times, because that would be like x to the 6th times 1, because again, that would add up to 7. So I know if I divide this, I'm going to have 6 divided by 2, and I'm going to have 1 left over. So again, 7 divided by 2, I would have 3, and then 1 left over. And again, the idea here is that we're taking and breaking down our x's. We could have had x to the 6th times x to the 1st. Again, 6 would have been divisible by 2. We would have gotten 3, and this would be like our extra. So if I think about just the x's, I would have x to the 3rd written on the outside. And I know that I would have x to the 1st left underneath. All right, let's look at another one, because again, it kind of is a little bit wordy, but once you get the hang of it, it's not too bad. So let's look at y's. So let's look at y to the 4th. So if I look at y to the 4th, if I take my exponent, which is 4, and divide it by my index, which is 2, this divides evenly. 4 divided by 2 is 2. So I know that I'm going to have y squared, and there's no extra. So when I do the division, this part is going to go on the outside. So like times y squared, and I have nothing left over. All right, let's try another one, just again, so we can see this again. If I have z to the 3rd, again, I'm going to take that exponent, which is a 3, I'm going to divide it by the index, which is 2. Now, this does not divide evenly. If I do this division, 2 goes into 3 one time, and then I would have extra. Because again, this could be broken down into like z squared times z to the 1st. Because again, if I added my exponents, that would be z to the 3rd. And again, I know that if I divided 3 divided by 2, there would be one time that they divided evenly. And then there would be an extra here. So on the outside would be z to the 1st. And then the extra would be z to the 1st, because that's the part that did not divide evenly. So if I rewrite this, then I would have 6i x to the 3rd y squared. Technically z to the 1st, but I don't need to write the exponent of a 1. And then underneath my square root here, my radical would be 5 x to the 1st. Again, don't need to write that exponent, times z to the 1st. I don't need a y because I didn't have any y's left over when I did the division. And this would be my final answer. So again, this is a little bit of a shortcut, just to make sure that you have some options. To be honest, like the shortcut is easier just to show you. It's hard to like explain. But you're looking for, again, groups that would divide evenly. And then if you have any extra, just like here with like when we did it the long way, see how if I had x cubed is the same thing as x squared times x to the 1st. And so notice right here, here's our group of 2. And that 2 matches the index. So that's why when I divided x to the first would go on the outside. And this is my extra, and my extra stays on the inside. So just another example of the shortcut. Again, not everyone has to use the shortcut, but I just wanted to show that to you all to see some of y'all might get that and use it. All right, make sure you're practicing and ask your teacher if you have any questions.